Hi everyone, welcome to Google Cloud Community Days 2023. In this session, we are going to see how we can go with serverless architecture using Google Cloud Platform. So let's talk a little bit about myself. Who am I? So I am Abhishek Sharma, Cloud Engineer at CS, which is Google Cloud Premier Partner. Also, I am a Google Cloud Champions Innovator in hybrid or multi-cloud domain. Also, Google Cloud Certified Professional Cloud Architect, a cloud mentor, blogger, and your friendly neighborhood teacher in one of the YouTube channel Guys in the Cloud. If you want, you can connect with me in either of the way. I write blogs, so you can check them out. So yeah, this is all little bit about myself. So without any delay, let's see the agenda, what we are gonna learn. So first we'll see what is serverless, and then we'll see what are the advantages we have with the serverless architecture, and then we'll see what are the different offerings we have in Google Cloud Platform and where to use those offerings in our real world use cases. Then we'll have one demo serverless deployment where we'll deploy our own portfolio application into one of the amazing compute serverless offering from Google Cloud. And then I will provide you some of the learning resources which you can refer to getting started with this amazing stack. So let's start with what is serverless. So if you see this particular slide, right, in the top right corner we have developer, in the top left corner we have user. So if I developed any application and I just wanted to serve that particular application to our end user, I have to do lots of things in between. So if you see here, first I have to choose infrastructure as service like compute engine VM instance, some other services. Then I have to set up the OS. Then I have to deploy the dependency, configure the networking, storage offering, monitoring and logging, and then testing, and then it can able to serve to the end user. So there are lots of works, right? Is it amazing if I just have to develop my application and it can easily serve to the end user? Is it amazing, right? So for that, if I told you we have a solution, and that solution is called as serverless. So in the top right corner, if you see here, in the serverless architecture, we just need to manage, we just need to provide our application to the cloud provider, and all the lower parts are handled by cloud provider itself. No need to worry about which operating system in which our application is running, what are the packages we have to install, what is the hardware and network configurations are over there. I just take my application, give to cloud provider, and they will handle all these things. But if you are using traditional methods like virtual machine on premises, we have some more dependency on the developers to manage. So if I'm using on-prem server, so I need to configure whole thing. If I'm using virtual machine, then I have to manage at this particular level. But in serverless, we just need to provide application. It is very easy. So ultimately, what is serverless? So in serverless, I just need to give the code and all the things are managed by cloud provider itself. So it is very straightforward and it is the smart move for you all. So let's see what are the advantages we have with the serverless development. So in cloud, we all know, right? We just have to pay for those services, those intervals which we are consuming. So in serverless architecture, whenever our application runs for at that particular point of time, we just need to pay for that. So it is very cost effective. There is no need to define any virtual machine or memory or CPU configuration. So there is no need to provision any VM because it is already handled by cloud provider. So it is very easy to scale down, or based on traffic or based on requirement. It is all handled by your cloud provider. So there is no management overhead, no upfront provisioning, and we just have to pay for those particular interval whenever application is running. So it is as simple as that. So let's see what are the advantages we have if we have serverless architecture in place with our application. So these are some of the advantages. So first is automatic optimized resources. So as there is no upfront provisioning and all the servers scaling, all these things are managed by cloud provider. So there is no such things are over there where we get into uh, infrastructure management. And also it will give you a flexibility that if suppose currently I have hundreds users coming into my website, and let's suppose after some time my website gets popular, so there are thousands of users which are coming to my website. So I need to scale my CPU and memory usage over there so that I can able to handle that traffic. I think this particular situation you also face in your whenever you work on some machine learning projects in your local laptops. After some time, if you have large data set, it gets stuck after some time to process that data. Same happens in cloud as well. But if you are using serverless, then it is all handled by cloud provider. So whenever there is a requirement to increase the memory and CPU power, it is handled by cloud provider and they will provide more CPU memory so that it can able to handle the traffic. And as soon as traffic goes down, it will automatically scale down. So we just have to pay for that particular limit or whatever resources we are going to consume, we just have to pay for that. Also, there is no dependency that we are managing our middle part or infrastructure management. We just have to put our code inside the cloud and all the things are managed by cloud provider and it is serving to that user. So it is very easy to faster time to market. We can easily adopt new technologies, new changes in our application. Also, it will help your developers to more focus on their application code rather than focusing on infrastructure management or scaling management or all such things. So these are some of the advantages. So ultimately, if you are using serverless, in your to-do list, there is nothing. You just have to provide your code. All the things are handled by a cloud provider. So now we know what is serverless. So let's see what are the different serverless offerings we have in Google Cloud Platform. So if you see in this particular slide, we have different pillars, different sections where we have different Google Cloud offerings as a serverless. So in compute, we have three offerings: App Engine, Cloud Run, Cloud Function. They have their own use cases. If you are seeking for any storage solution, then we have Firestore and Cloud Storage Bucket. So if you ever interacted with Cloud Storage Bucket, we just need to go to Cloud Storage Bucket console, just provide some few details like what is the bucket name, in which particular reason I want a bucket, and it will provision a bucket for you. There is no such requirement that I define I need this much amount of memory, CPU, whatever data I have in petabytes, in terabytes, I can put over there. And it is already handled by cloud provider. So it is very easy. There is no requirement to provide any information related to infrastructure. Also, if you are seeking for analytics, there are a variety of services we have in Google Cloud, like BigQuery, Dataflow, PubSub for data pipelining, and uh, do some kind of analytics in your data. Apart from that, if you are want to create some kind of load balancing as a network service, wanted to do some kind of AI/ML thing, also if you want to enforce security, all these things, all these services we have in Google Cloud as a serverless. It means there is no infra management. I just need to provide application, all will be handled by cloud provider. So these are list of services in Google Cloud Platform. So let's deep dig out into serverless compute options. So we already saw these three offerings from the last slide. So first one is cloud functions. This is also called as function as a service. So let's suppose you have some small code snippet which you want to run So let's suppose I just wanted to message or mail my friend whenever there is a birthday. Okay, so I just written one code snippet, put it into a cloud function. It will automatically run whenever my friend's birthday is over there. So this you can able to build using cloud function. Here also you no need to provision any infrastructure, provide some details over there related to how much CPU or memory you want. After that, we have one more offering in compute, that is App Engine. So this is also called as platform as a service. So sometimes what happens, if you have your entire application stack and you just want this application to be up and running very quickly. So you just need to provide this is my application, these are the dependency, and put give to the cloud provider. Your application will be running within a minute in the cloud, and there is no need to get into these things that if currently we have tens of users and in future we have lakhs of users, how I am gonna scale the environment, how I can handle the backend, how I am enforcing the security. All these things are handled by cloud provider itself. So this is second offering. Third and the last one in compute option is we have that is Cloud Run. This is also called as container as a service. So basically current era is more like a microservice based. uh, every company is wanted to run their application into microservices based architecture. So for that kind of use cases, Cloud Run is one of the most popular and widely used service in Google Cloud Platform related to serverless. You just need to provide your container, and within a minute your container will be live, and we are gonna do one demo on this particular service where we'll host our portfolio site using Cloud Run. So I think most of you folks are not familiar with containers, what it is, right? So let's suppose if you have your application and you have built your application on Python. But if you move the same code to someone else's computer, so let's suppose I build my application in Mac and my friend is using Windows. So if I give my application to my friend, maybe chances and most of the time it is happening that that application will not work in their platform because I built that particular application in Mac and my friend is using Windows, because every applications and its dependency is very different, right? So for that, what we done actually, we just taken our application, we just taken their dependency and we packaged that dependency with their application and created a bundle, and that bundle is called as container, and it is isolated from the operating system, it is isolated from each other, and I can run this container anywhere, right? So this is as easy as much. So let's see what are the benefits we have with container. So let's suppose whatever application language you want to build application on top of that, you can able to run. Containers are very portable, so we can easily move from one location to second location. So if I am running my container in AWS, I can run the same container in GCP or Azure or in my local laptop. So this is very easy. As I already told you, it is isolated and it is not dependent from the host operating system. So let's suppose I build one container in my Mac. I can run the same container in Windows as well. So it is very easy. Also, containers are isolated from each other, so we can segregate memory and CPU power to different containers if we have thousands of containers in place in my local. So it is very easy. So let's talk about Cloud Run in more depth. As I already told you, this is container as a service, and this will help you bringing serverless to containers. How? So basically, if you have your container in place, you just need to give this container to Cloud Run, and automatically whatever network configuration infrastructure you want, it is already handled by cloud provider behind the scene. You just need to provide your container, and within a minutes your container will be live. And we are going to do the same thing with our portfolio site in the demo part. Also, this is request based auto scaling and no operations required. So let's suppose if you have currently tens of users, and after that, if you have lakhs of users, it can automatically scale up and scale down based on the traffic requirement. So this is very cost effective. Whenever there is a high traffic load, then I have lots of VMs created behind the scene by cloud provider. But after some time there is no load, then it can scale down to zero. So there is no additional cost over there. So we just need to pay for that particular interval whenever our application is live and serving to the end user. And it can able to run some kind of event driven based scenarios. So let's suppose we have PDF converter kind of application, so in which our application will only run for that particular time interval whenever user comes to my website and uploads their different kind of file which needs to be converted into a PDF, right? So I just have to pay for that particular interval when users, when my application is processing users different kind of file system into PDF. So I just need to pay for that. If there is no users coming in my website, then there is no additional charge over there. So it is amazing, right? This is very cost effective with included of different monitoring and logging solutions, so that if there are some issues in your application, you can handle, you can troubleshoot very easily. So in the same manner as we have some specifications in the containers, here also we have the same kind of specification functionality. So you can run any containers of any languages. You just have to pay for that particular interval where your application is processing or running your backend. Also, it is fully managed HTTPS endpoint. So most of the time it is a concern that whenever we host our application, we need to configure HTTPS traffic so that it can securely serve to the end user, and it is automatically or managed by cloud provider. So whenever we deploy any application in Cloud Run, it will give you one HTTPS endpoint. We just need to hit that endpoint and application is live. So this is very easy. Also, its backend is fully managed as this is a serverless offering. We just need to provide application. All the things are handled by our cloud provider. So it is that much easy. So let's talk more about pay-per-use model. How we are gonna charge for a serverless offering. So if you see here in the diagram, we have two requests. One request is starting from this particular point in a green, and second request is starting from this red one, and it is terminating to this particular interval, and it is terminating to this particular interval. So let's take the same example of PDF converter. So some user comes to my website, okay, and uploaded their file. So from this particular point, file uploadation is done. In the same manner, second user comes to my website and uploads their different kind of files. So for the green one, I have my website, my backend is taking this much amount of time to process that data and convert it into the PDF. In the same manner, second one is also taking this particular time interval to process that different kind of file to convert it into PDF. So if you see here, I just need to pay for this particular time interval. For that, my application, my Cloud Run serverless offering is running behind the scene. But in the same manner, if you host your application into your virtual machine, so all the time I have to make sure that my application, my virtual machine is running behind the scene. So for whole time interval from this particular time, if there is no user to this particular time, I have to pay for that particular interval. So it is more costlier than this particular approach where whenever a user come, then and then my application is running and then I have to pay for that particular interval where my application backend is running. So it is very cost effective. Now let's see some of the use cases of our Cloud Run serverless offering. So if you want to host your website, so like in the demo part, we'll see how you can host your portfolio application into the Cloud Run. So you can host your application using Cloud Run. Also, you can build some mobile backends, API endpoints, or webhooks using this particular offering. Also, if you are working in a private domain where you don't want to expose your Cloud Run application to the end user, and you want to do some kind of internal communication or internal API development, or wanted to build some kind of microservices which is utilized inside your application. So you can feel free to build these kind of use cases using Cloud Run. Now, happy part is let's see the demo how we can host our own application into one of the most popular serverless offering in Google Cloud, that is Cloud Run. So in this demo, what we are gonna do, first we'll take one portfolio website, we'll containerize that application or website. So in which what we are gonna do, first we'll take our application, take their dependency, create a bundle, and that bundle is called as container image. Then after we'll store this container image to container registry, which is Google Cloud Container Registry, and from where we are gonna deploy this application into the cloud, and within a minute we'll see our application is live and accessible to the end user. So let's go to the console. So first, let's see how I have created a portfolio website for me, which we are gonna host into our serverless offering. So let's go to the folder. Here you can able to see I have asset folder in which I have included all the CSS and JavaScript files. Also, I included some images which are used in my application. Also, I have one index.html file. Also, I have Docker file, which we are gonna use for creating our Docker image. And also we have some other folders over there in which I have added some demo images over there. So let's click on index.html. So here you can see this is my portfolio website where we have about me section, what I'm doing, some testimonials, and some of the organization in which I have involved in. This is my resume. These are my skill sets. So this is pretty straightforward portfolio website. So as you know, we are gonna deploy this particular application into our serverless offering called Cloud Run. And Cloud Run is also called as container as a service. So currently this is my application code. I need to containerize this application, then and then I can able to run it over Cloud Run. So for doing that, let's see the second step, how we can able to create container image. So to create an container image, I am going to use Docker, which is most popular containerization tool uh, and open source as well. So for that, let's go to console.cloud.google.com. You can install Docker in your local and you can create container over there. But here I am going to use Cloud Shell, which is one of the best offering from Google Cloud itself, where we get all the normally used packages like kubectl, docker, helm. So whatever developer uses, all those softwares are pre-built installed in this particular cloud cell, and it is free of cost, so anyone can able to just go and use it. So let's assume this particular cloud cell is your local laptop. So currently in my local laptop, I have the code. So first I need to take my code here. So for doing that particular thing, let's create one folder called portfolio. Okay, let's get into that folder. Eh, Now, in Cloud Cell, we have one more feature called upload. So just click here. I just wanted to upload a folder. Here you can define in which destination directory you want to upload folder. Choose folder here. Go to documents. Here is my folder and just click upload. Yes. So all these files are gonna uploaded into my Cloud Cell. So just click here. So here you can see all the files are uploading, and after some time we'll see all the folders over there. So this is pretty much straightforward virtual machine in Google Cloud Platform, which is already having all the dependent software used by different developers. And Docker is one of the most popular tool, which is commonly used by developers to create images, to manage images, and to work with the images actually. So this is still uploading. Okay. Also, you can check here as well. So here you can see this particular folder comes up. Let's get into this folder. You can just drop down here. Okay. So here you can see I have the asset folder, Docker file, index, and all those folder which we have in my local are uploaded to my Cloud Cell. Okay. Now we need to create container. So how to create container? So in the previous slide, I already talked about what is container. So we just take our application, take their dependency, and we bundle it, and that bundle is called as containers. So to create your own container, we need to create a Docker file first, in which we define what are the steps we need to follow, what are the dependencies you need to install while creating containers. So let's see how I have structured this Docker file. So I just use this cat command. Okay, this is basically a Linux command. So here you can see from Ubuntu latest. So what I'm doing, I am taking one operating system as a base. On top of that, so let's suppose you have your Ubuntu machine. To run your application, you need a web server, right? So first I need to install that particular software. So for that, apt get update, install, all these commands are mentioned here. Then after whatever files I'm here having here, like assets, index.html, all those files I'm copying to this particular location, which is the default folder of any web server in which our application will be hosted. And after that, I'm using here expose keyword, which is used to expose your container. So in the previous slides, we have learned about this particular thing, that our container is isolated from other environments or from the operating system, but it require one endpoint from where it can be accessible to the outside world. And that point we define here using the expose command, and here we are exposing via port number 80. You can use either port, whatever you want. And after that, at the end, we are running Nginx. So in the normal VM, what we do, systemctl start Nginx. So in the same way, we are using the same kind of command here to start our Nginx. So yeah, our all the files are uploaded here. Now let's create our container. So to create any container, you just need to have some clarity on some of the Docker commands. So first command is docker build, and then you can use -t command to tag your container. And then after you can use either name, but here I am using some specific name nomenclature, gcr.io. It is reference to your container registry. Here we are gonna use Google's container registry. So GCR is reference to Google Container Registry. So normally what we do, we create our container and we store that particular container in a specific repository or location. So in normal cases, most of the people or in open source world, we store those containers into the Docker Hub. But here we are using Google Cloud. So let's store our container into our Google's container registry. So first type gcr.io slash then your project ID. This is our project ID. Okay. After that use slash. This is my of portfolio folio and then let's tag it v1. And after that I'm using dot. So there is a significance of dot. Dot in Linux means current folder. So whenever you run docker build command, there is an option that you can able to provide in which particular location you have docker file, or you can just place your docker file in the current directory and just type dot at the end of your docker build command. So I used dot here. So if I click up arrow, so here you can see this particular command I have run to create my docker image. So just to validate what things happen in the backend. So here if you see 8 by 8 is mentioned over there. So whatever steps I have mentioned in this Docker file. So first step is take the Ubuntu image and then run some command, and after that copy whatever file I have in this particular folder, and after that expose it over port 80 and then start the nginx. So all these steps are executed when I run this docker build command. So to validate my docker image is created or not, just type docker images. So here you can see 54 seconds ago I have created this particular image. Okay, now let's test that our application, our container image is running properly. So for doing that, we have one more docker command, that is docker run. Docker run, then you can use -it, then you can use -p command. This is used for mapping purpose, port mapping. -p means port map. So we already talked about this particular thing that our container is isolated from the environment. But what we can do, if we have our container and this is our local laptop, we can map both of these components so that we can see whatever things are running in my container. I can able to see those contents in my local laptop. So for doing that particular thing, I have to map the port in which my container is exposed to my some of the local port. So let's suppose in my local cloud cell or in your local laptop, I am having port number 8080, which I am mapping to port 80. How I came to these two ports? So 8080 port is random, which I have chosen by my own, but the second 80 port is reference to this particular expose port, which I have defined while creating my container. So basically, this is the port in which my container is exposing. So that's why here I am using 80 number port. After that, you just need to define the container name. You can use any name as your choice. You can tag. So currently this is version 1, then version 2, version 3, whatever you want, you can take it here. Okay. So if I click hit enter, in Cloud Cell itself, we don't have the GUI, but we have port mapping feature here called Web Preview, in which you can able to see whatever running on port 8080. So let's suppose if you have mapped this particular Cloud Cell to your container over 5000 ports, so you can change it accordingly. So let's see on port number 8080 in which our container is currently running and mapped to our Cloud Cell, it is serving the expected output or not. So just click on preview on port 8080. So let's see. So tada! So our container is running as expected. So it is serving my portfolio website for which we have created the container. It is also having all the functionality which we already saw in my local. Also, it is serving our resume. So here you can see this is different one, and this one is my portfolio, which is locally. So now my container is running properly. Let's let me show you different port as well. So just Control C to exit from here. Let's suppose I want to map my local's port number 5000 to container port 80. I can able to do that particular thing. So here you can see I have added 5000 and then colon 80. 80 is my container port and 5000 in which I want to see. So just hit it again. I think, okay. So I need to remove from here. So now my container is running. Click here. But currently, if I click preview on port 80, it will not show expected output because it is showing preview on port 80. But we have changed that particular port to 5000. So just click on change port, type whatever port you have mapped, click change and preview. So here you can see over port 5000 we can able to see the same expected output. So now our container is running as expected. So let's move to the next step of our slide where we store our container image to somewhere, and for us that somewhere is called as Google Container Registry, where most of the organizations store their application containers. Because if you store your container in Docker Hub public repository, so it should be accessible to uh, all the world, right? But in organizations, what we do, we want some repository which is very private and we have full access to those repository. So Google is offering that kind of registry called Google Container Registry, where most of the organizations will store their containers. So let's move our container which we developed in our local cloud cell to that particular location. So for doing that particular activity, we just need to run this command docker push and whatever name we have. So basically, there is a reason of taking this name, long name actually, gcr.io, then model docker and all, because just authorize here. Okay. So if you have ever interacted with Docker Hub or ever created any Docker container, so if you want to push your container registry container to your Docker Hub, you need to define the URL of your Docker. So it is a resemblance like docker.io slash then your repository name and something like that. So in the same manner, GCR is reference for Google Container Registry. This is the location. This is our project because this is shared service. So everyone is putting their containers into location under Google Cloud, right? But how my Docker push command will recognize that this is the user's project in which I have to push my container. So for that, we are referencing this is the Google Container Registry where I want to push. This is the project ID in which I have to push, and this is the name of the image, and this is the version. So this is successfully added. So let's see in the console if we can able to see this or not. So just search for GCR, which is reference to Google Container Registry. This is the first option. Click here, and here we have a images section. So if I see here portfolio, because we named our image as portfolio and it is having version v1. So if I just click here in the portfolio, just hold on. Okay, here you can see we have one image and which is tagged as v1. So as I already told you, we have tagged it using v1. So now we have our container ready and we stored that container in somewhere. So let's go to the next phase to deploy it into our serverless offering. So for that, just type here, click on Cloud Run. This is the first service. Just click here. Okay. Now there is no such service. So let's create one service. Click here, create. Here it is popping up for deploy and revision from existing container, or you can deploy a new revision. So in organizations, what we have different versions for different applications. So let's suppose we build our application version 1. After some time, we patch new services, new functionality in our application, and create a new image called version 2, same as version 3, 4, 5. So you can define like this is a newer version of my application, or I am creating a new particular service from very scratch and it is having version 1. So just hit enter, click on the container images. So here we have portfolio and this is our version v1. So just select here. It automatically popped name portfolio because our container name is portfolio. You can change it accordingly. Also, let's choose Asia South 1. That is our Mumbai region. Asia South 1 Mumbai. Now just go down, set all things default, allow unauthenticated invocation here. So remember when we created Docker container image, we exposed our image over port 8080. So we need to define our container port or expose port here and take the other things by default, and let's hit enter create. Also you can see here currently I am using free tier and it is showing what is the cost, what is the consumption rate we have here. So just click on create. So in normal cases, if you want to host your portfolio site, you need to create a VM, you put your code over there, you need to install dependencies like web servers, and on top of that, you need to set the MIGs, manage instance groups, so that it can scale up, scale down accordingly. Also, you need to configure the load balancer, then DNS mapping. So all those things are handled by cloud provider here. I just got one URL. So I'm just copying here and go to my site, just pasting that link. And here you can see my portfolio website is live. It is very easy, straightforward, right? Here you can see it is connection is secure, all HTTPS network configuration, all those things are handled by cloud provider. So currently I am the only one who is accessing this particular website, right? Maybe chances that after some time your application gets more popular and more number of users are getting into this particular application, then how it gonna scale? We don't need to worry about. All those things are managed by cloud provider because this is a serverless offering. So this is how you can take your own portfolio application, containerize it, store it into somewhere, easily Google Container Registry, and after that how you can deploy it into Cloud Run. So I have given you a walkthrough how you can do this particular activity from the console, but you can do this using gcloud command line tool as well. After that, some more functionality we have, which I just wanted to showcase you. So if you see this particular URL, it is very rough one, right? Portfolio, then QB66 something. No one like this kind of DNS, right? You want DNS like abhisheksharma.com, flipkart.com, something like that, right? So to do that particular activity, you can able to configure your DNS here as well. So we have the functionality that you can able to map whatever DNS name you want with this particular application. Also, sometime what happens in the production or in the organization, people want that whenever a developer pushes any code to the GitHub, it will automatically create container. It will automatically deploy to our Cloud Run deployment. So that is also possible with the Cloud Run. Just click on this setup continuous deployment where you just have to provide some access to your repository. You just define whatever repository you want in which your code is reside. Also, you can configure some advanced configurations here, and then after just configure it. And whenever a developer pushes their code to GitHub, it will automatically fetch those changes, build a new container image, and deploy it here. That is also possible. So with Cloud Run, with this serverless offering, you can do CI/CD as well. Okay. So yeah, this is all for getting started with this amazing serverless offering from Google Cloud. If you want to explore more, then we have set of learning resources for you, which will help you do some advanced things, build some uh, complex microservice based architecture. So let's go back to the our presentation. Now, these are some of the learning resources you can refer to learn more about this amazing technology. So, if you want to prefer learning from a documentation, so just search for cloud.run. If you want to do some kind of lab practice, then go for google.quicklabs.com. Also, if you get into advanced concepts of Cloud Run, so just go to this GitHub link. Also, if you want to implement some of the use cases, then we have this demo implementation link here. You can refer and getting started with this amazing technology. So yeah, this is all from my end, guys. Thank you. Have an awesome journey.